We're talking about transformations of quadratic functions, and we want to graph functions in standard form and determine whether a graph has a minimum value or maximum value from the given a value. So problem 3, find the minimum or maximum value for the function f of x equals negative 2x squared plus 4x plus 3, and describe the domain range of the function and where the function is increasing and decreasing. So the first thing that we have to do is we have to calculate the axis of symmetry. So first thing we're going to do is calculate the axis of symmetry, which we have the equation x equals, the negative is always there, always the same, the divide is always there, and the 2 is always there. The thing that changes are we substitute in b and we substitute in a. So from the given function, we know that a is equal to negative 2. We know that b is equal to 4. And c is equal to 3. So we can substitute those values in, and we get x is equal to, the negative stays, the divide sign stays, and the 2 stays. The only thing that changes, we substitute in a negative 2 and a positive 4. And what we get is negative 4 over negative 4, which is equal to 1. So that's our line of symmetry. X is equal to 1. Now, something that helps me out is always to say, look at the a value. So the a value is negative 2. So we know that our parabola is going to look like this because it's going to open down. So we know that we are looking like this looks like a mountain, and the top of the mountain, that's a max. So we are going to be looking for a max at the vertex. And the way that we calculate the vertex is we plug it back into the equation. So we have the function f, we're going to evaluate it at 1, and that's equal to negative 2 times 1 squared plus 4 times 1 plus 3. So we're going to substitute the 1 in all those locations. So 1 goes there, 1 goes in for all the x's. Then we just have to do our math. So 1 squared is 1 times negative 2 is negative 2. 4 times 1 is 4 plus 3. And when we add those together, we get a value of 5. So what that tells us is our vertex, we got our x value from our line of symmetry, and that gave us our y value. So our vertex is 1, 5. And then that is going to be our max value. So another thing that helps me is just paying attention to the graph. I don't have to sketch the whole graph in order to decide where it's increasing and what the domain is. So here we have the vertex is 1, 5, and then we should be able to figure out all the other information from there. The domain, that's the x values. So the domain is always, this goes from negative infinity to positive infinity. We can never count to infinity, so negative infinity to positive infinity. The range, that is all the y values. Now, for a parabola, one side's always going to go to infinity, and the other side is going to stop at the vertex. In this time, we're talking about the y values. So this one goes down to negative infinity. this goes down to negative infinity. So we start at the lowest, which is obviously negative infinity. We're not going to get any smaller than that. And then we go up to the highest y value. So the highest y value is located at the vertex, which in this case is going to be 5. And 5 is included, so we got to make sure we change that to a bracket. Now, increasing and decreasing, that has to do with our domain, and we split it into two parts. We split it into increasing and decreasing. So increasing, we start at negative infinity and we make it all the way to the vertex, which the x value happens at 1. So increasing from negative infinity to 1. 1 is not included, and negative infinity is not included. Negative infinity because you can't count that high. 1 is not included because the slope at the vertex is 0. It's neither increasing nor decreasing. Then we continue decreasing, and we start up at 1. 1's not included, but right after that is included. And then we make it all the way to positive infinity. If we look at example 4, it is a similar question. So find the minimum or maximum value, then describe the domain and range, and increasing and decreasing. It's the same steps. So we want to use our equation for the line of symmetry, or axis of symmetry, and that is x equals negative b over 2a. And then we substitute our values in. So a is equal to 1/2. B is equal to 3. And C is equal to 7. Right away, we have a is equal to 1/2. So because the a value is equal to 1/2, we know that we're going to have a graph that opens up because it's positive. And that means that we are going to have a minimum or a low point. So if we think about that like a lake or a glass, there's going to be definitely a bottom to it, and it's going to continue up because the a value is positive. So we can substitute those values into the equation, and we get x is equal to the negative stays, the divide sign stays, and the 2 stays. The things that change are the a value becomes 1/2, and the b value becomes 3. And we substitute those in, and we end up with negative 3 because 2 times 1/2 is 1. And so we end up with x equals negative 3. So the vertex happens on the axis of symmetry. So we can substitute those values in, or substitute negative 3 in to the function and solve it and figure out what that is. So this time we're talking about the function h evaluated at negative 3, and that's going to be equal to 1/2 times negative 3 squared plus 3 times negative 3 plus 7. And we can substitute the negative 3 in for all the x's. And what we get is negative 3 squared is 9. 9 divided by 2 is 9 over 2. 3 times negative 3 is negative 9 plus 7. So this is equal to 4.5 minus 9 plus 7. And what we get is 2.5, which is equal to 5 over 2. 5/2. So that is our y coordinate, and what we get is the coordinate of -3, 5/2. And that is our vertex, which is a minimum. So now that we have our minimum, I like to do a quick sketch just to help me remember where everything is located. So I know that my parabola is going to open up, and I know that my vertex is going to be at -3, 5/2. So domain, the domain for parabolas, it always goes to -infinity and to +infinity in the x direction. So -infinity to +infinity. For the range, that's the y values. The range always starts at the lowest and works its way to the highest. So the smallest portion here is going to be 5/2. And the vertex, or the minimum and maximum, is always included. So we put that bracket there to show that it's included. And then those arrows mean that it goes to +infinity. And +infinity is not included, so we use a parenthesis. Then we have increasing or decreasing. So decreasing, in this case, we start out, we start high and work our way low as we read the graph left to right. So decreasing is going to start at -infinity, and it's going to go all the way to the vertex, which is -3. So neither one is included. So we're going to go from -infinity to -3. Neither one is included. And then for increasing, from -infinity, because we're going to start right at the vertex, and go to +infinity. Now, -3 is not included because the slope at the bottom of the vertex is 0. So that's why -3 is not included in either increasing nor decreasing. And we can never count all the way to infinity, so that will not be included.